we've got 2 cos squared theta plus cos theta equals 1. So what's your first step? Subtract the 1. Sorry, minus 1 is equal to 0. Yeah. You're then going to write it as 2x squared plus x minus 1 is 0. Okay, now what are you doing?
Well, like normally if it's a term that you can split, I would split it if it was like, say 7x. Oh, I need a okay.
So what multiplies to make minus 2?
Yes.
You have to do that step first, don't you?
Yeah.
And that would be positive 2 multiplied by negative 1. That's how you split the middle term.
Oh, okay.
So you must do that multiplication bit. So then that becomes 2x squared plus 2x minus x minus 1. 0. Splitting it gives 2x and x plus 1. And this becomes minus 1 lot of x plus 1. Which is then 2x minus 1 multiplied by x plus 1. And what do you do at that point? That then becomes 2 cos theta minus 1 and cos theta plus 1. And the null factor law states that that one has to equal 0. That one equals 0. So start with this one. Cos theta is negative 1. So just check in 0 to 2 pi. So I know from cosine that that's when theta is, cosine is like this, 180. Yeah? So it's at that point, isn't it? Yeah? So 180 degrees, but that's pi. Yeah? And then what about this one? So now we've got cos theta is equal to 1 divided by 2, cos theta is half. So now we need our special triangle for that one, don't we?
Yes.
So that's the 30, 60, 2, 1. So cosine is adjacent hypotenuse, so that's 60 degrees. But in terms of pi, 60 degrees is pi of 3. But there's also another one, isn't there? Cosine is, remember the unit circle now. That's cosine at that point would be the half.
Yeah.
So we then, so when it's 60, but then also when it's 300.
360 minus 60. Oh, yeah.
So 300, sorry. But what's that then? That's 2 pi minus a sixth of pi. So it's 1 and 5/6. So 11/6 pi.
Wait, is it a minus a third of pi?
Sorry. Yeah. Why have I written a sixth? Should be a third. I was thinking those numbers don't make sense. That should be a third of pi, and then so 2 pi subtract 6. That would be 5 pi over 3. So we now have 1, 2, 3 possible solutions. That makes sense. So yeah, it's that. Looks like it's that first bit. Remember, when you're splitting the middle term, you have to multiply to figure out what you multiply by. So then I am going to factorize the second one. Right? So minus 1, x plus 1. Now I'm trying to get the same factor. All right? That's the point. I need the same thing here and here. So once I've got it on one, I'm looking for that in the other one, right? Then I factorize again. And what's the common factor in both of these parts? It's the x plus 1, yeah? So that's this bracket. what do I need to multiply x plus 1 by to get all of this? 2x minus 1. So that's in the other bracket. Yeah. Okay, so you've got 6x squared minus x minus 1. So you've got minus 6, so that's positive 2. So you've got 6x squared minus 3x plus 2x minus 1.
Yeah.
So that's 3x, 2x
minus
1 plus 1 lot of 2x minus 1.
Yeah.
So then that's 3x plus 1 and 2x minus 1.
Equals 0.
So we've then got 3 cos theta plus 1, and we've got 2 cos theta plus 1.
Yes.
Okay, so you've then got cos theta is negative a third,
Yes.
and you've got cos theta is negative a half.
Wait, no, isn't it a half?
So yeah, that should be a negative one. Right?
Negative.
Yeah, so that should be positive a half. All right, so
the second one is just the same as the question we did before.
yeah, so what have we got? Theta is
Pi over a third, and also 5 pi over a third.
okay.
And then for the other one, since there's no special triangles or anything,
Yeah,
the inverse cosine of negative a third is 109.47.
but radians. You're giving me in degrees.
How do you switch modes again? Mode. Yes. Okay, I got it. All right. Now let me see what it does.
It's quite a nice one, actually. So we do the same thing. We can consider it as 2x squared plus 2 minus root 2x minus root 2. We multiply, and you've got negative 2 root 2. Now you've got to, this is why it looks difficult, but it's actually relatively easy. You've got to find two things that multiply to make that and add to make that. And if I look at it, this is 2 add negative root 2. And this would be 2 multiplied by negative root 2. So that's how I split my term. So I've got 2x squared plus 2x minus root 2x minus root 2. Split the middle term. So I've got 2x and x plus 1. And here I would have minus root 2 x plus 1. That gives me 2x minus root 2 and x plus 1. Okay with that? So then we just go back, and I'm pretty sure you're okay with the next stage. So then it becomes 2 sine theta minus root 2 is equal to 0, and sine theta plus 1 is equal to 0. So that's sine theta is negative 1, and this would be sine theta is root 2 over 2.
Because I got that sine theta plus 1 equals 0.
Yeah.
Because I did it a different way, where I expanded the 2 minus root 2.
Oh, okay.
And then I squared the whole thing to get 2x to the power of 4.
All right.
Yeah.
Wow.
And then, it didn't work out when I factorized it.
No.
So.
Are you happy with what we did here, though? Just the basic? Yeah? What do you do at this point, guys? Is this
You can get that out of the special triangles.
Yeah, so what's that the same as? That's 1 over root 2, isn't it? Yeah. So we can start recognising that one. So that's cool.
Why is that the same as 1 over root 2?
Because if you rationalize the denominator, you multiply both by
By
root
root
2.
2.
Remember we talked about it yesterday. Yeah.
And so root 2 times root 2 is 2, and 1 times root 2
Yeah.
is root 2.
And she's feeling better. All right. Now, I find the way they do it a little bit confusing myself, but I can see why they do it. I'm going to talk you through this the way I would consider it. So sine 2x is equal to root 3 divided by 2. Now, let me just ask you this. What is the difference graphically between sine of x and sine of 2x? What does it do?
Isn't it wider?
It's more.
Yeah, so sine of x looks like this, doesn't it? Yeah? And what does sine of 2x look like? Remember it?
The amplitude is twice as.
No. The frequency is twice, isn't it? So remember when we sketched it, we kind of put these construction lines in. The 2 is how many wavelengths in 360 degrees, right? So we'd have it like this. All right. So if I wanted to solve sine of 2x root 3 over 2, suddenly I'm going to get more solutions, right? But what I can do is I can say, and this is what they've done, so I'll go that way. Let's have a look at what it would be if I said sine of u, okay, is equal to root 3 over 2. I'm not going to call it x because that would confuse matters. Right? I'm going to give it a different term because I'm not solving sine of x. I'm trying to solve sine of 2x, right? But let's do sine of u. So sine of u is equal, well, what is u going to end up being? Well, what's root 3 over 2? One of the special triangles.
Which is the 60 degrees.
So that was the root 3, 2, 1. This will be the 60. This is the 30.
Yeah.
So root 3 over 2 is sine of
No. Yes.
60, yeah?
Yes.
Opposite hypotenuse. So u will be 60 degrees, or should we do it in radians? Actually, no. Let's do it in degrees. 60 degrees. All right? Are there any other values? Let's say it's between 0 and 360. Okay? We're going to solve between 0 and 360. So just u, do we have any other solutions? So this is the black line that I'm working on. Are there any other solutions? Where? Stephen? So 60 is going to be about here. That's root 3 over 2. So the next one is going to be 180 minus 60. So u is 120 degrees. Okay. All right. So in the book, they start mentioning a bit like, oh, let's consider a different domain. But I don't like to think like that. I just think, right, if those are my two solutions for u, all right,
Yep.
what would my solutions be if u was actually 2x? Now, what happens if I double the wavelength? Well, all my solutions just get half as big, right?
Yeah.
So instead of having u being 60, I'm going to rewrite it as 2x is equal to 60 and 2x is equal to 120. Yeah? Got that?
Yeah.
So what is x going to be? Well, x is going to be 30 and x is going to be 60. And that will match, you know, on the orange there and there. But then I will also have, because I now have two wavelengths, I will also have a couple more. All right, so x will now have x also equaling 180 plus 30 and
plus 120.
No. 270 minus, or however you wanted to do it, yeah? So that would be x is equal to 210, and this would be x is equal to 240. So I would actually have 4 solutions in this given domain.
Yeah.
All right? But it's relatively simple because there's no magic. If I've got 2 waves, all my solutions just get halved. Now, that's the principle. It's explained slightly differently here. But what I want to draw your attention to, if you have a look at practice 2 on page 238, what do you notice about the domains that they've asked you to solve?
On 238?
238 there,
Okay.
yeah. They've changed the domains. So they're asking you only from 0 to pi, for instance. All right, only from 0 to pi. Some are 0 to 2 pi, so you're going to have to get more. So you have to be careful that you do. So I've just gone 0 to 360 degrees, but sometimes if, for instance, I know there's going to be 2 waves in 360, they might say only do it up to 180 instead, and that keeps the same number of solutions. Okay, so that's where they're saying, right, if I want to solve sine of 2x equals, what was it again? Root 3 over 2 for the domain 0 to pi, all right, I would actually need to solve sine of u is equal to root 3 over 2 from 0 to 2 pi. So the way I like to do it myself, it makes it better in my head, is that I just shrink the graph and then consider afterwards how many solutions I have. What they do is they think of it the other way round and they extend the domain of the new one. All right? Either or, you end up at the same situation. But me personally, I like to visualize, oh, well, I've got this many wavelengths, so I need to consider, rather than expand or shrink the domain. But you've got both options there. The way they do it in the book is to adjust the domain, not consider the curves. Up to you how you want to go about doing it. So the rest of it is pretty much as is. You've still got the factorization, the solving, but you've then got that final step at the end. Make sense? So you can carry on practice 2. It will only add